Understanding weaknesses and the vulnerabilities in a system or network is really a huge step towards correcting the vulnerability or putting the appropriate countermeasures in place to mitigate these threats. There are different types of security vulnerabilities, and in here actually I'm labeling or going over a few examples. These vulnerabilities can be things like policy flaws, design errors, protocol weaknesses, even a misconfiguration in a system, software vulnerabilities, and we will cover a few examples later in the course. Human factors is another example of vulnerabilities and is what people often refer to as the weakest link. We will also cover social engineering and some of the human factor vulnerabilities later in the course. Malicious software, hardware vulnerabilities, and even physical access to the network resources are also some other types of vulnerabilities. All right, let's actually get started with some more examples of software vulnerabilities. The first one that I would like to cover is buffer overflows. And a buffer overflow is a type of vulnerability when an attacker causes a program to write data to a buffer and then overrunning the buffer boundaries, and by doing so, overwriting memory in adjacent locations. Buffer overflows can be triggered by sending crafted packets or specific inputs that are designed to execute code or alter the way that program was originally designed. In this example, there's a buffer called my buffer. The original data that I'm displaying here is hello world. Now, what we actually want to do as an attacker is actually overwrite that data beyond the container. And in this case, we're actually overwriting it, and in my example, I have hello every world. In there, you actually saw that the memory was overwritten, and in this case, was filled across the boundary. Now, there's another definition whenever it comes to buffer overflows that I would like to mention here, and is the instruction pointers. The memory register that is overwritten with the return address of the exploit code is known as the instruction pointer, or EIP. There's a joke within the hacker community that, if you actually are successful, you actually want to obtain EIP because it holds the address for the next instruction to be executed, and it's only valid pointing to an executable, valid if pointing to an executable memory region. So by doing that, you can cause, other harm into the device. So what is the stack? The stack holds all local variables and parameters used by any function. It basically remembers the order in which functions are called so that the function returns correctly. When a function is called, the variables parameters are pushed into the stack, and when the function returns, these local parameters are popped off the stack. So what does the mainframe look like on the stack? This is how the mainframe looks like when we put more than 512 bytes in the buffer. It looks like what we actually are showing in this screen now. Basically, the safe EBP and the EIP were overwritten, and in this case, we actually sent a whole bunch of A's to the program to actually overfill the actual buffer. Again, the goal is to control the execution flow and target the EIP. And of course, maintain control of the system without crashing the system so the attacker actually can manipulate or remotely send instructions to the system to carry out an attack. This is a little bit more in depth of what you actually need for the CCNA security exam, but I wanted to provide you with a good example of this type of vulnerabilities since buffer overflows have been heavily used by attackers for years. Another common example of vulnerabilities is cross-site scripting vulnerabilities. Cross-site scripting is basically the ability to execute JavaScript code with the browser's document object model, otherwise known as DOM. In non-web speak, run scripts in a user's context. There are different types of cross-site scripting vulnerabilities, stored and reflected. In the stored cross-site scripting vulnerabilities, the web application stores the attack in the database for later display. In reflected cross-site scripting vulnerabilities, the attacker immediately attacks the user based on specific inputs. Typically, this is performed via social engineering or by fooling the user to follow a malicious link. So what is the threat from cross-site scripting? The threat include the stealing of browser cookies, browser controls, and force actions, and of course enhance social engineering to fool the user to either provide user credentials or follow a malicious link where later malware can be installed in their PC. Here I include a link to an open source tool called the Browser Exploitation Framework, or BEEF, that can be used to find cross-site scripting vulnerabilities in your environment. There are many others such as AppScan, Burp Suites, and some others, Wanted to actually provide you at least with one example in this slide. Another type of web-based vulnerabilities is cross-site request forgery, or CSRF. This is what we call the cross-site scripting cousin. It exploits the trust a site has in its users, typically through social engineering and of course by fooling a user to follow a malicious link. And in this example, the screen shows how I can leverage a function to withdraw money from a user called Alice and then put that money into a user called Mallory's. So again, this is a really simplistic example, but there are many ways to carry out cross-site request forgery attack. Another common vulnerability is a SQL injection. Developers typically don't sanitize user inputs before using it in SQL queries, and this is an example of it. Attackers can take advantage of this to either steal information, delete data in a database, or even putting information in such database. In this screen, I include a link to the Open Web Application Security Project, otherwise known as OWASP. And in their site, they actually have many other vulnerability definitions and categories for your referencing here. So of course, there's hundreds of vulnerabilities, and we can spend a week going into each one of them. But I wanted to actually provide you a reference at the end of this lesson so you can become familiar with this type of vulnerabilities.